Hey guys, Miss Albanese. We're ready for lesson 8. I can represent measurement data with line plots. I don't think I even have to tell you what any of those words mean. We've been doing line plots for a few days, and we already know that representing data means to just graph it on the line plot. So we are going to skip down and oh, look what we have. Be sure you do your pattern sheet. And I'm going to switch this to here. Okay, so before we get started, I want to count by halves and fourths. Let's count by halves to 12 halves. And as I show them on the board, say it out loud, okay? 1 half, 2 halves, 3 halves, 4 halves, and you keep going. "12 halves. Okay. Let's find the fractions that equal the whole number. Well, how many halves are in a whole? 2 halves are in a whole, so we're going to say, let me get my pen. Here we have 1 half, 2 halves we know is 1, 3 halves, 4 halves would be 2 because there's 1, 2 halves in a whole. So 1, 2 halves would be, 6 halves would be 3. 8 halves would be 4. 10 halves would be what? Yep, 5. And 6 would be 12 halves. Oh, look, just like yesterday, I see something. 6 times 2 equals 12. 5 times 2 equals 10. 4 times 2 equals 8. We just cannot get away from that multiplication. That must be a really important skill to have, to know your multiplication. I hope even though we're not at school doing our multiplication videos every day, I hope you're still at least doing them some days at home, because that's something you never want to forget, is how to do your skip counting and your multiplication. All right, let's move on. Now we're going to count by fourths, halves and fourths. Let's count by fourths, all the way up to 12 fourths. Ready? Oops. Hang on. 1 fourth, 2 fourths, 3 fourths. Now you go. Say it out loud. 12 fourths. Let's find the fractions that equal a whole number. Count by fourths again, but say the wholes when you get to them. Okay, we know there's 4 fourths in every one, or every whole. So there's 1, 2, 3, 4 fourths. 8 fourths. That's 1, 2, 3. 1, 2, 3, 4. So again, we're going to go 1, 2, 3. Oh, there it is, 3 fourths. And look, 3 times 4 is 12. 2 times 4 is 8. 1 times 4 is 4. Or we could do our division. 4 divided by 1, 4. 8 divided by 2, 4. 3 divided by 3, 4. Application problem. Get out your scratch paper. Miss Burns' class is studying worms. They measure the lengths of the worms to the nearest quarter inch. Too bad we're not together so we could measure some worms. Wouldn't you love to see those squiggly, dirty little worms laying there on your desk with a ruler and you have to stretch them out and measure them? Think you would enjoy that? Some of you probably would. I think I would not. But Mrs. Burns' class is doing it, so they measure the lengths of the worms to the nearest quarter inch. The length of the shortest worm is 3 3/4 inches. The length of the longest worm is 5 2/4 inches. That was a long worm. Kathleen says they will need 8 quarter-inch intervals to plot the length of the worms on a line plot. Is she right? Why or why not? Well, we've just got to try it and see, don't we? Let's draw our line. And we've got 1, 2, 3, 4. We have to have at least 5 2/4, don't we? So let's put our halves in. Let's go all the way to 6. Okay, and then we've got to put our quarters in. Half of a half, right? Okay, so this one is going to be 0, 1, 2, 3, 4. I need to make it longer because the longest one, goodness, look at that line. What a mess. It's going to be 6. We'll do our half and then our little quarters. Okay, because our longest one is 5 2/4 or 5 1/2. So our longest one is going to come right here. Catherine says they will need 8 quarter-inch intervals to plot the length of the worms. Let's see if she's right. Let's count our quarter inches. 1, 2, 3, 4, 5, 6, 7, 8. So Catherine says that this is enough. Is Catherine correct? Or is she wrong? If you said she was wrong, you're right. She's wrong. Why is she wrong? Think about it for a minute. See if you can come up with a sentence that tells me why Catherine's wrong. Well, I think Catherine's wrong because 8 quarter-inch intervals would only be 2. And the longest worm was a lot longer than that. It was 5 1/2 inches longer, 5 2/4 inches. So that would definitely be a lot longer than just 2. Let's see how many quarter-inch intervals it would be. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. 22 quarter-inch intervals. Okay. Now let's look at the heights of some sunflower plants. Ooh, we love our sunflower plants, don't we? Mrs. Schnott. How would you like that to be your teacher? Mrs. Schnott measures the height of sunflower plants in her garden. The measurements are shown in the chart below. Okay, let's take a look at it. Ooh, those are high, aren't they? What data is shown on the chart? Well, the data that's shown is right here in the title, the height of the sunflower plants in inches. Okay. How does it compare to the data in our last session? Well, the data in our last session was much smaller. It was 1 inch, 2 inch, 3 inch, 4 inch. So these are a lot taller. So we're going to make a line plot to show this data. What would be our end points? What are end points? Well, I would have to have my biggest one here or my smallest one here. What do you think? This is my small end. This is my big end, right? So let's find the smallest end point. 61 is smaller. Do we have anything small? Oh, 60 is smaller than 61. Do we have anything smaller than 60? Nope. Looks like our end point here is going to be 60. And what would be our largest? Oh, 63 is larger. Is there anything larger than 63? Oh, yeah, there's 64. Anything larger than 64? Greater than 64? Nope. Looks like 64 is our other endpoint. So we've got to have endpoints, or not endpoints, but points in between, don't we? Let's see. We're going to have 61, 62, and 63. So 62 is going to be here. 61 is going to be here. And 63 is going to be about here. Okay, so 61, 62, and 63. Okay, now I'm looking at this and I'm thinking our scale is going to need to be 1/4. I don't see any 1/4. Do I see any 3/4? Nope, I only see halves. So we only have to put in halves. So we're going to have 60.5, 61.5, 62.5, 63.5, and 64. Okay. Now, I need to find all of the ones that are 60 exactly. So I'm going to find 60 exactly. There's one. Did I miss any? I don't think so. So on 60, I have one. And let's see, 60.5. Let's look for 60.5. Oh, there's one, 60.5. Oh, there's two 60.5. 1, 2. And let's find any that are 61. Oh, there's 61. 2 61s. 3 61s. Oh, 3 61s. I wish I had all these beautiful flowers in my garden. I love sunflowers. They might be my favorite plant. I've got some in the classroom, don't I? But they're not real. Okay, so let's find the next interval is 61.5. So, oh, I see 62.5, 61.5, 61.5. That's 2 of those. Oh, 3, 4. Oh, no. Gotta go back and erase. Because I don't want 63.5. I want 61.5. All right, so kind of messed myself up, didn't I? But that's okay. 61 and a half. There's three 61 and a halves so far. Looks like 3 61 and a halves. Okay, next interval would be 62. 62, 63, or 62, 62, that's 2 of those. Another 62, that's 3 of those. Oh, 4 and 5. Ooh, that's more, isn't it? 3, 4. 4 that are 62 inches high. It's tall. Okay, I've got to go from 62 to 62 and a half. Next interval. 62 and a half. There's 1 of those. 2 of those. 3 of those. 4 of those. 5. 6. Wow. I think so far that's the most. Okay, 63. Got 1, 2, 3, 4. And the next interval would be 63 and a half. 1, 2, 2 of those. I just noticed a mistake I made. You guys see it? I have another one that's 62 and a half. That's okay. I can come over here to 62 and a half and just add it right in. Next interval is 64. Oh, there's another 63 and a half I missed too. So let's find the 64s. Any 64s? 1, 2. So let's mark them out. 1, 2. Did we get everything? I think we did. 1, 2. Okay. Wow, look at that. Okay, let's go to the next slide and we'll talk about it. See, theirs is much nicer than mine. And they went ahead and they made their, what is this? Remember what this is called? That's the title. This shows the intervals. And this shows that 1x equals 1 sunflower plant. Tell me a true statement about the heights of the sunflower plants in Mrs. Schnott's garden. One true statement. Well, I think that I could say that 60 inches had the least amount of flowers at 60 inches. And I could also say there were the most or the greatest amount of flowers at 62 and a half inches. I could also say that 61, 61 and a half, and 63 and a half have an equal amount of flowers at that height. And let's say, which one would have at least, how many would have at least 63 and a half inches high? Which ones are at least 63 and a half inches high? Well, we know that if we're saying at least, it's the ones that are more. So it would be 1, 2, 3, 4, 5. 5 flowers are at least 63.5 inches tall. So those are using all those great new words, those new vocabulary words we've been working with. Okay. And look at that. We already did it, didn't we? Oh, but here, write a number sentence to show how many plants do not measure 62, 62.5, and 62 inches. What? Write a number sentence to show how many plants do not measure 62, 62.5. I think that's supposed to say 63, maybe, because that doesn't make any sense otherwise. So we would have to say 62. They do not equal 62. 62.5 do not. And 63. So we would have to say 1 plus 2 plus 3 plus 3 plus 3 plus 2. And let's see what that's going to be. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14. Oh, we're to our problem set. So hopefully you've already got your scratch paper and pencil and you're ready to go. See you on lesson 9.